Hi students, I think I'll do this worksheet in two separate videos. I think it will be too long to do it in one. So let's do example 1 and then I'll do example 2 later. A power function is a function that can be represented in the form a times x to the p power, where a and p are real numbers. So we have f of x equals a times x to the p power. A is the coefficient and p is the power. The highest power of the function is called the degree of the function. This form that the polynomial is in is called the factored form because it's factored, or it's also called the intercept form. Because if we set each of the factors equal to 0, we will find the intercepts. So if we set x squared equal to 0, we would get plus minus 0 or just 0. 0 isn't positive or negative. If we set x plus 2 equal to 0, then we get x equals negative 2. And if we set x minus 1 equal to 0, we get x equals positive 1. So I know without even looking at the graph below, I know the x-intercepts are 0, negative 2, and 1. So let's check it out. So 0, negative 2, and 1. So on the line that asks for the intercepts, I could just go ahead and put that. Negative 2, 0, 0, 0, and 1, 0. Those are the x-intercepts, and 0, 0 is also the y-intercept. So we've got our intercepts completed. The factored form or the intercept form can be FOILed together or multiplied together to find the original polynomial. So let's check that out, see if we can do that really quickly. We have x squared times x plus 2 times x minus 1. I'm going to save the x squared for the last step. I'll multiply everything by x squared at the very end. So I'm going to FOIL. X times x is x squared. X times negative 1 is negative 1x, or negative x. 2 times x is positive 2x, and 2 times negative 1 is negative 2. So we have f of x equals x squared, which I'm saving for the end. I'm combining like terms inside my parentheses. A negative 1x and a positive 2x gives me positive 1x, or just plus x, minus 2. I will now distribute the x squared to the terms in the trinomial. X squared times x squared is x to the 4th power. X squared times x is plus x cubed. X squared times a negative 2 is negative 2 x squared. And there we have the polynomial function. Notice the highest power is 4, and we say the a value, or the leading coefficient, is this 1. So the highest power is 4, and a is 1. So you remember we talked at the beginning about f of x equals a times x to the p power. So 4 is the power, the highest power. The highest power is called the degree of the polynomial. And a is called the leading coefficient, because coefficients are the numbers in front of the x's. And the 1 is in front of the highest power. This is in the lead. This is the leading coefficient because it's out in front. All right, they've graphed it for us. We can look at our graph to find the domain and the range. You know, domain is where we say what x's we're using. Since this graph broadens as it gets higher, it's going forever to the left and to the right. Our domain will be all real numbers, or in interval notation, negative infinity to positive infinity. The range, recall the range is the bottom y value to the top y value. So the bottom y value, I would say that's maybe negative 2.9, and the top y value is, of course, positive infinity. So we would say the range, bracket, negative 2.9, comma, infinity. So negative 2.9 is solid. That's why we use a bracket beside it when we use the interval notation to infinity. It is continuous because we never have to pick up our pencil to draw it. So it is continuous. The values over which the graph is increasing and decreasing. Remember that a graph moves left to right. So if we're moving from the left side of the graph to the right side of the graph, this part of the graph is decreasing down to this point right there. So I want to know over what interval is my graph decreasing. So I would say it's decreasing between negative infinity and negative 1.5. That's the interval over which my graph is decreasing. So I'm going to say decreasing interval, always use parentheses, negative infinity to negative 1.5 parenthesis. Okay, as we move on, the graph looks like it's going up. My y values are greater than they were before. So that part of the graph is increasing. So the part of the graph that is increasing is between negative 1.5 and 0. Remember, this is where we use our x-axis to determine, or to explain, really, to explain where the graph is increasing or decreasing. So it's increasing between negative 1.5 on the x-axis to 0 on the x-axis. Those are the x values. Then notice that the graph is going down, down to right there. So it's decreasing in that little interval, and we would say that where is it decreasing? Between 0 and, I don't know, 0.8. So we have to kind of guesstimate just a little bit. It's decreasing between 0 for an x value and 0.8 for an x value. Okay, then it starts to increase again. It starts going back up. And our increase is on the interval 0.8 to positive infinity. It's going to use all of those x values. So 0.8 to positive infinity. All right. Moving on, the max and the min. So I'm going to erase this so we can see our x-axis a little bit better and our points just a bit better. All right, so our max and our min. So the max would be the high point. So, and that's called a relative max, but we'll just call it a max at 0, 0. And we have two minimums. So our minimums would be, and we're guesstimating, negative 1.5, negative 2.9, negative 1.5, negative 2.9. And the other minimum right in here, positive 0.8, negative 0.2. Positive 0.8, negative 0.2. All right, those are both minimums, and the max is 0, 0. All right, the leading coefficient. So they're asking us in that f of x equals ax to the p power. They're asking us what is a. It's the coefficient out in the lead. So A is 1, and the degree is 4. The degree is the highest power. So the leading coefficient was 1, and the degree 4. The end behaviors using limits. So this is probably the new thing. Well, no, it's not the new thing. We have done this many times. Okay, so let's use limits to describe our end behaviors. Our graph has two ends. I'll circle them. So this is one of the ends and this is the other end. And I'll just write the limits up here so that we can have it close. The limit of f of x as our x values are approaching negative infinity, because this is moving to the, it's not only getting higher, but it's also moving outward to the left and to the right. So our x values are approaching negative infinity. Our limit, which is our y value, our y values are approaching positive infinity because this is going to go up forever. So our limit equals infinity. Okay, now on the other side, the other end behavior, the limit of f of x as our x values approach. So this is moving to the right forever. Not only is it going higher, but it's also moving to the right. So our x values are approaching positive infinity. Our limit, or our y values, are approaching infinity. Okay, that is the first example. So I think we'll stop here and I will record the other example.